This is a video for Scatterplots, Part 3, writing the equation for the line of best fit. We have looked at in the previous videos what a scatterplot is, how to construct one, how to tell what the association is, if it's positive or negative, strong or weak. We've learned how to draw a line of best fit and use it to make predictions. And so today we are going to learn how to write the equation for that line of best fit. Now, just to review, the line of best fit is a straight line that represents the trend of the data on a scatter plot. How do we know where the line of best fit should go? We should put it through the center of the data and try to have as many points above the line and below the line, or get as close as you can as possible to the center. And why do we need one? We need a line of best fit because it's easier to make predictions on a scatter plot when we have a line to anchor everything back to. So let's review a little bit. Which line best fits the trend of the data shown? So which one is the best line of best fit for this set of data? All right, so now that you've had a little bit of time to think about it, let's look at B. B would be one that we eliminate because B does not trend with the data. Yes, it is in the center of the data, but it could not help us make predictions about this data. When we look at A and D, these lines do trend with the data, but we have several points above this line and only 1 point below this line, so that's not going to be a very good representation of our data. Same thing here, we just have more points below our line than we do above our line, so it's not a very good representation of our data. But look at C. C has a line of best fit that goes right in the center of the data. There's 1, 2, 3 points above it, 1, 2, 3, 4 points below it, and so C is going to be our best option there. We use a line of best fit to make predictions. This is a scatter plot that deals with the lowest priced airfares from Baltimore. We have our distance and our fare according to the distance in a scatter plot, and we have drawn a line of best fit. It makes sense that as the distance increases, your fare, your money that it's going to cost to get an airplane ticket is going to increase there. The line of best fit is right in the middle of our data. It doesn't touch any of the points, and that's okay, just as long as there's as many points above as there is below. What is a good prediction of the price of a ticket that has a distance of 1,600 miles? So I'm going to let you look at 1,600 miles and decide how much that ticket might cost. Here's 1,600 miles on our graph. So if we follow it up to our line of best fit, it looks like it would be about right here, and in the middle of 240 and 280 would be 260. So about $260 would be a good prediction for how much a ticket would cost for 1,600 miles of travel from Baltimore. The second question asks, a ticket costs $200. What would you predict the distance traveled to be? So look at your graph, look at your scatter plot, find where a ticket costs $200, and predict how many miles from Baltimore you would fly for $200. So if we look over here at our fare, there's $200. If we go over to our line of best fit, it looks like we could travel about 1,000 miles. All right. Now, that's our review. Now, today what we're going to be doing is using the slope and the y-intercept of the line of best fit to write the equation. Remember, we write equations in y equals mx plus b form. You've gotten some practice on that in the last week. And we are going to write them in this form, where m is the slope and b is the y-intercept. And then we're going to use the equation to make predictions. We're also going to discuss the meaning of the slope and the y-intercept as it pertains to the situation. So sometimes it's easy to use the equation of the line of best fit to make a prediction from the scatter plot. Now, for example, the distance to Hollywood, California is 2,667 miles from Baltimore. What would be a good prediction of the price of the airfare to Hollywood based on this scatter plot? If we look down here at our scatter plot, if we want to look at 2,667 miles, our graph only goes out to 1,600 miles. So we're not able to use this graph to be able to predict the amount of money it's going to cost because we run out of distance here. But if we write an equation for this line, we can use that equation to make that prediction. So let's look at how we would do that. Now, remember we're writing it in y equals mx plus b form. And we're still looking at the same graph right here. All right, so the first step is going to be to find the slope of this line. Now, there's a couple ways to find slope. So we need to know what our m is. If we find the slope using our slope formula, y2 minus y1 over x2 minus x1, you will need to choose 2 points on this line of best fit. It does not have to be any points included on the scatter plot. It just has to be on this line. So 2 points that have been chosen for us, remember they need to go right through the crosshairs, right through 2 integers so that we know where the points are at 200, 120. And 1,200. Those are our 2 points. So over here, we have those written down, 200, 120, 1,200. Y minus y would be 200. Let's label our points. Y2 minus y1 would be 200 minus 120. X2 minus X1 would be 1,000 minus 200. So you get 80 over 800, and that is 0.1. So our slope is 0.1. The second step is to find our y-intercept. Remember, this is just where it touches the y-axis, and if you look over here on our graph, you can see that it touches the y-axis right here. Now it seems that we are counting by 20s, so that would be 100 right there. So you see that our B is 100. So when we write our equation for the line of best fit, where we have our M, just replace it with 0.1, and where we have our B, replace it with 100, so it looks like this. Y equals 0.1x plus 100. Now, if we want to make that prediction of how much it's going to cost to go 2,667 miles. Since our x-axis is our distance, we replace x with 2,667 miles, multiply it by 0.1, and add 100, and you get $366.70. All right, let's do another one together. This is a multiple choice question, and it's asking you to interpret what the slope means. Now, we determined this equation in the last example, same example that we have this time. We determined this equation. Which of these correctly interprets the slope of the line? Now, remember what our slope means. It means how much our y is increasing for each x. So every time we travel 1 mile, how much is the fare increasing? That's what slope means. So if our slope is 0.1, that means that we are increasing $0.1 for every mile that we are traveling. So look down at your answer choices. Which one states that the fare, your money, is increasing for $0.1 for each mile? So just to use the process of elimination, we did not say that it is increasing $100 every 0.1 mile. It's not increasing $10 for each additional mile. It's not increasing $0.1 for every 100 miles, but it is increasing $0.1 for every additional 1 mile. So D is going to be our answer. Now it asked to explain what the y-intercept could represent in this situation. The y-intercept is 100. Remember, $100. That's where our money, our fare in dollars, is starting. So even if we don't, when we start our flight, we are going to always start at $100, and then for each additional mile, we are going to add $0.1. So it is the starting point. It is the initial value of the airfare. You can read that. The initial value of the airfare. All right, so we're going to do this one together. I know it says you try, and if you want to try this, you are more than welcome to stop the video and then wait for me to explain it, and then just press play again to see if you have done this one correctly. But I'm going to work this one with you now. Write an equation for the line of best fit. So that's our first task. Now over here, we're going to go to our graph, and anytime I want to write an equation, I write down y equals mx plus b. Now I like to identify my b. That's the easiest thing to identify. It's where my line is beginning right here. And guess what? I'm not sure exactly where that is, but I'm going to predict that that's going to be about 9. Now I need to find my slope. I'm going to choose 2 points on the graph. I'm going to pick 0 and 9 as one of those points. And my other point I'm going to choose will be right here at 10.25. So y2 minus y1 over x2 minus x1. 25 minus 9 is going to give me 16. 10 minus 0 is 10. So it looks like my slope is going to be 1.6. All right, so y equals 1.6x plus 9. My slope is positive because my line is increasing. Use your equation to predict the length of the spring if 15 weights are added. Now look back over here at our line. Do you see that the number of weights only goes out to 10? And we want to know what the prediction is, the length of the spring, if it's 15. So we're going to have to go back and use this equation. Since the number of weights is our x, we're going to replace 15, our x with 15. So we have 1.6 times 15 plus 9. I'm going to have to do that manually because I don't have a calculator handy. No, I'm sorry. I did that wrong. 24 plus 9. 33 inches. 33 inches. What does the slope mean in this situation? So we're talking about 1.6 being our slope. And remember that our slope is always how the length of the spring, our y, is increasing for each x. So we want to know how many inches our length, our spring is increasing for each number of weight. So the length of the spring is increasing 1.6 inches for every weight added. Length of the spring increases 1.6 inches for every weight added. And what does the y-intercept mean in this situation? That when there is 0 weights, that the length of the spring starts out at 9. So the initial length is 9 inches. Sorry. And we can use this equation to predict the length of the spring for any number of weights. We just have to replace that x with the number of weights, and we can predict the length of the spring. We can also predict how many weights if we had the length of the spring, but we would just replace the y with the length of the spring. All right, here's you try number 2. If you want, pause it, write the equation and answer questions 1 through 4, and then press play to get your answer. I'm going to start out with y equals mx plus b. I'm going to go ahead and replace our b with where the line touches the y-axis, and it looks like it touches right there at 24. Now I need to find my slope. My slope is always going to be y2 minus y1 over x2 minus x1. I'm going to choose 2 points on this line to find my slope. I think I'll use 0, 24. And let's see, looks like I can possibly use 548. So I'm going to do 48 minus 24 over 5 minus 0. 24 divided by 5 is going to equal 4 4/5. X plus 24 is going to be the equation of my line. I could also write that as y equals 4.8x plus 24. That might be easier for you to use with a decimal if you're making predictions. It asks to use the equation to predict how much Jim would earn if he works 14 hours. Since our graph only goes out to 10 hours worked, we have to use our equation. Hours is on the x-axis, so we're going to replace x with 18. I'm going to multiply 4.8 by 18. Again, I don't have a calculator on me, so I'm going to go up here and do it manually. And I get y equals 110.4. So the dollars earned would be 110.4. I'm going to add a 0 since it's money. $0.40 for 15 hours worked. The slope in this situation is how many dollars earned, what is the increase of the dollars earned per hour worked? So $4.80, since that was our slope, is going to be $480 per hour worked. And what does the y-intercept mean? It means that before Jim works any hours, his pay starts at $24. All right, so let's look at matching up some line of best fit equations using multiple choice. Which of the following is the most reasonable equation for the line of best fit? This is where your elimination skills are going to come in handy. We're looking at 4 equations in y equals mx plus b form. We know, we've learned in class that we start eliminating answers using our y-intercept. Our y-intercept is at positive 25, so we can go ahead and eliminate b and d. Our slope is negative. It is decreasing, so we can eliminate a because that gives a positive slope. So C is our line of best fit. And it asks which of the following is the most reasonable estimate for about the wind chill with a 60 mile per hour wind. Now you notice our graph does not go out to 60, so we're going to use this equation. We're going to plug in 60 miles per hour. 60 wind speed is our x. And calculate. So that concludes our Scatterplot teaching videos. If you have any questions, please email me or Mr. Holliday or Miss Butler, and we will be able to answer any of your questions. You are ready now to do Thursday and Friday of week 5 assignments.